All right, so here we have another improper integral, only this time the lower bound is minus infinity. So, we're just going to treat that lower bound then as t, right? We're just going to assume it's some finite value to begin with and then look at the limit as that value goes to in this case, minus infinity. So I'm going to integrate from t to 0, x e to the x dx. All right, do you remember how to solve this? This is an integration by parts integral. All right, so what we're going to do is we're going to say u is equal to x. So du is equal to dx. And then we're going to say dv is equal to e to the x dx. All right, so that means that v has to be e to the x. All right, so now we're going to we're going to get u times v, right? So x e to the x, and I'm going to evaluate that from t to 0, right? Minus the integral of v du, right? So we're going to get e to the x dx. All right, well that's easy enough. So when I do that, I'm just going to rewrite this. It's going to be x e to the x minus e to the x. And I'm going to evaluate the whole thing from t to 0. All right, that's easy enough. Let's do that. We get 0 times e to the 0 minus e to the 0. Okay. And then we have minus t e to the t minus e to the t. Okay. Now 0 times e to the 0 is 0. And then we have e to the 0, which is minus 1, right? So minus e to the 0 is minus 1. And then we have this e to the, we have this minus t e to the t. And then we're going to have plus e to the t. Okay. All right, so now we've evaluated the integral at t, and so we want to look at the limit, as t goes to minus infinity of this minus 1 minus t e to the t plus e to the t. All right, well, part of this integral is easy, right? The 1 is just minus 1. But, whoops, minus 1. But this is the problem here. So we got the, let's see. Let me go back. Limit as t goes to minus infinity of t e to the t. All right, that's the one we're going to have a little trouble with. But then as t goes to minus infinity, e to the t goes to 0. Okay, so so we just need to figure out what this middle term is. So if you look at this middle term, when t goes to minus infinity, the t goes to minus infinity, of course, and then the e to the t goes to 0. So we got this kind of infinity times 0 thing going on. So we have to do something to rearrange it. So, all right, and then we can apply L'Hopital's rule. So let's look at t, the limit as t goes to, minus infinity of, and let's rearrange this. Let's make this t over e to the minus t. And that way we have it in the form where it's going to minus infinity and infinity, right? So we have infinity over infinity kind of situation. So with them, then we can apply L'Hopital's rule. So apply L'Hopital's rule. Okay, so we're going to take the derivative of the top and the derivative of the bottom. So we get the limit as t goes to minus infinity of 1 over minus e to the minus t. All right, so I'm going to rewrite that just so it's easier to see what's going on. So limit as t goes to minus infinity, and that just becomes minus e to the t, right? Because essentially e to the minus t is 1 over e to the t, and so it flips up to the top. And if we evaluate that as t goes to minus infinity, right, we're going to get 0. Okay, so that's 0. Okay, so that's good. So all we have left is that first term, which is minus 1. So that's telling me that this integral from minus infinity to 0 of x e to the x dx is equal to 1. Oops, to 1. Okay, so that's my final answer. That integral is just 1.